Hey guys, so I actually had a video of me cutting out this 4x4 inch proto board, double-sided through hole plated. It was kind of funny because it shot out of my hand and I almost died, but it's totally cool, you know, nice and clean cut. So why am I doing this? I need to make an op amp, a dual op amp. So I was actually using this JRC4558D dual op amp. I'm using this as part of the digital to analog converter for the fan controller for my case. You can see that I use the socket there, and good thing I used the socket because I figured out why it was actually backfeeding, and it was actually backfeeding through the output transistors because the op amp runs off 12 volts because these are not a rail-to-rail op amp, so that means that it can only get up to 75% of its volt, or approximately 75% of its actual like voltage. So if I ran this off 5 volts and I wanted to output 5 volts through the op amp, then it would only put out like 4 point something volts. So what I need is a rail-to-rail op amp. Now, I don't have rail-to-rail op amps in this package, but I do have it in a surface mount package, a SOT23 package. What we're gonna do is basically use this piece of proto board right here. We're gonna attach some legs to it so it's a direct drop-in replacement for this guy, so I don't have to modify the board other than setting the 12 volt rail to 5 volts instead. So I'm actually going to just make a drop-in replacement using some surface mount chips. Okay guys, so I have inserted my wires. So these aren't bond wires, obviously. These are lead wires. Because I have a bunch of lead wires because I'm doing something for work. And I ended up cutting a lot of leads. So I have a bunch of lead wires. As you can also see, I live in California. It is like 1,000 degrees outside, and normally I would be doing this outside or in the spare room that I used to do stuff in, but outside is bueno. And yeah, but right now with this heat, no bueno. Especially right now, it's like 4 p.m. or actually it's a little bit past, and the sun is just beating down on my bench outside. So I've kind of moved in here for the last couple of days with my O-scope, both my power supplies, all my component kits. My mom is like, "What the fuck are you doing, man?" Luckily, we got 2 tables. So yeah, only downside is the smell of soldering. Not the best thing. But that is why we got an air filter. So when you make these kinds of boards, you gotta put on your thing, put a bit of flux. So we need the flux on there because we want strong connections. You could just rely on the flux that comes with your solder, but not always the best. So I just paint on some flux. It's a bit cold. My soldering iron's already heated up. Gotta kind of wipe it. It's pretty dirty. So when doing something like this, because we want the pins lined up perfectly, also you have to cook it a little bit longer just to make sure that the solder goes all the way through the hole, because we want nice strong connections since this will be plopped in. So we just want to solder all those pins. It's okay if they're not straight right away because we can always just bend the pins to their final angle. But we do need to make sure that these are very strong connections. Good amount of soldering lead, or 60-40 tin, whatever the heck floats your boat. I'm not an ROHSE kind of thing, and that stuff ruins tips. So yeah, I'd prefer to keep my Metcal tips since they're so damn expensive. I'd like to keep them pretty pristine if I can. So yeah, that is it. Now we're gonna chop off the extra leads, super glue on the chips, and yeah. I got the data sheets for both of my chips, so I have a data sheet for the JRC 458, which is a dual op amp. It follows your very standard classic pinout of a dual op amp. Now the LM321 is a SOT23 package, or SOT23, and it's actually pretty similar to the LM324, which is a pretty shit op amp. But I mean, I'm very, like, I use it a lot, the LM324, mainly because I have a bunch of them, and I have them in surface mount, the LM324, and I also have them as through hole. But for this case, it's actually pretty good because it is a minimum 2.7 volts, maximum 5.5 volts. It is a guaranteed, like, 2.75 volt, no crossover issues. The V minus is 0 volts, so that means it's a true rail-to-rail or a rail-to-rail operational amplifier. The LM324 is actually not a rail-to-rail, but it can be depending on how you set it up, I believe. But yeah, these are the 321 M5. So yeah, I have a giant reel here. Oh, okay, I spent $5 on it. 1,000 pieces ROHS. It even tells you how to melt it if you want. Boop, boop, boop. Oh, my bad. So yeah, 1,000. Never been used because I just haven't had the time. And I also have some of these. So I have 1 microfarad surface mount capacitors. I believe they're 0805, or no, they're 1206. So 1 microfarad, 16 volts. Yeah. So yeah, I'll be using this as our stability-ness. I'll just use one of them. Looks like this has never been used, but yeah, this is not a quantity of 1,000. It's like 200 something. But yeah, so I'm just gonna dead bug style those onto here. So I'm gonna super glue it, and then I'm gonna solder it, and let's see. Ouch, that hurts. It's a little crooked. Fuck it.